Good morning. This lesson is from our Trig-Precalc classes, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it, how I title it, and the title. But what I am sure of are two goals for the day. Our first goal is going to be to solve linear trig equations, and our second goal, which is going to be incorporated, is going to be to understand how solutions can be restricted and what form the solution is in. Now, solving trig equations is actually easier than you think. And one of the things that students struggle with is they struggle solving for something that looks like this, sine of theta. So what we're going to do is we're going to replace sine of theta or cosine of theta with an x, and we're going to solve for this x and switch back to the sine of theta or the cosine of theta. And you'll see that by doing this, you make this problem, which might seem a little bit difficult, much easier to solve. Now, I also have written on the board steps to solve linear equations. And our first step would be to eliminate fractions by multiplying everyone by the denominator. Our second step will be to distribute. Our third step is to combine like terms on each side of the equal sign. Our fourth step is to get all variables to one side of the equal sign using addition or subtraction. Our fifth step is going to be to add or subtract away a number from the variable side of the equal sign. And the clue for this is there's a plus or minus between the number and the variable. And our sixth and final step will be to divide away a number from the variable side of the equal sign. Now, these 6 steps are meant to act as a guide, because some students struggle with knowing what to do first and knowing what to do next. And so if we make a list of 1 through 6 and work our way through these steps, that'll guide us through the solving of these linear trig equations. I also have on the board a very minimal unit circle where I have 0 degrees or 0 pi, 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, or 360 degrees or 2 pi. I'm going to be referencing these when I talk about the second goal, understanding how solutions can be restricted. And finally, for this first part of the lesson, I have 2 examples I'd like to solve, and I have some restrictions on what the answers can be. And notice that these are identical problems. So let me go ahead and solve and show you how we would do this part, use the 6 steps, and then understand where our answers can be. All right, so let me go ahead and solve this. So the very first thing I'm going to do is I'm going to rewrite this equation with an x instead of a sine of theta. And I now have 3 plus x is equal to 6 plus square root of 3 all over 2. Now I'm going to write 1 through 6 next to this as a guide to help me solve this problem. Now let's see here. Okay, so the first thing we can do, and by the way, you can solve these in different ways, but I find that my students tend to do well if we follow these 6 steps. Alright, so the first thing, can I eliminate a fraction by multiplying everyone by the denominator? Yes, I can. Now, this is actually considered one number, so this is only going to get multiplied by 1, 2. This gets a 2, and this gets a 2. So this is what it looks like to eliminate a fraction. Now I can cancel out my fraction. My equation now becomes 6 plus 2x is equal to 6 plus square root of 3. All right. Can I distribute? Meaning, do I have parentheses? No, I cannot. Can I combine like terms? Not really. And no. So I can't do step 3. Are all my x's on one side of the equal sign? Yes, they are. So I can't do step 4. Step 5, do I have a plus or minus between a number and a variable? Yes, I do. So I can actually do step 5, and I can subtract the 6 to both sides. So that cancels out, that cancels out. I'm now left with 2x is equal to the square root of 3. All right. Now, can I divide away a number from the variable side of the equal sign? Yes, I can. I can divide both sides by 2. So now I get x is equal to square root of 3 over 2. But remember, x replaced my sine of theta. So that means sine of theta is equal to square root of 3 over 2. Now let's make sure we understand what this little equation is asking us. It's asking us, now I know I'm talking about degrees. So this is about degrees. Now let me write that in here. This is about degrees. which means that we're talking about angles. Okay, so when I'm talking about my answer, it has to be in degrees. Okay. And being that I can go from 0 degrees, including 0 degrees, all the way to 360 degrees, what that means is I'm allowed to consider an answer from anywhere on the unit circle. So anywhere I have highlighted in red represents 0 degrees to 360 degrees. All right, so here I'd say there's an unknown angle that has a y-coordinate of square root of 3 over 2. So there's an unknown angle with a y-coordinate of square root of 3 over 2. Now, the unknown y-coordinate, the unknown angle would be at 60 degrees or at 120 degrees. So the answer to this problem is going to be theta is equal to 60 degrees and 120 degrees. Now, you're going to want to have your unit circle out when you look at this. I have a very minimal unit circle. I didn't want to write in all the values because it's going to really crowd the whiteboard, but trust me, it's at 60 degrees, right? Yeah, it's at 60 degrees and 120 degrees. So this equation has two solutions, and again, I use my 6 steps to work my way through this problem. There is a simpler way to solve it, but again, I find that my students do quite well with this method. Now, I have a second example here, and let me put a line through this so we can see. This equation is actually the same as this equation. They're the exact same. But what's different is I've restricted the answer into a different location. So the answer is allowed to go from 90 degrees to 270 degrees. So I'll erase where the answer is not allowed to be. So the answer is only allowed to be in this area. That's what this is saying. And there's only one angle that's in that area that has a y-coordinate of square root of 3 over 2. So the answer to this problem is going to be theta is equal to 120 degrees. Even though there's another location where I have a y-coordinate that's square root of 3 over 2, it's only allowed to be restricted in this area, so it would be 120 degrees. So let me go ahead and erase this, come back with another form that our solution can be in. I'll just create another problem and again show you how the restricted answer is going to work. So let me clean all this up and I'll be back. I'm back. So let's go ahead and continue with our lesson on solving linear trig equations, understanding how solutions can be restricted and understanding what form our solution is in. So here I have, again, 2 examples, the same equation, different restrictions. Now, these restrictions are telling me that our answer is going to be in radians. The answer is going to be in radians. So we're talking about length, right? So the solution is in radians. Okay, so the first problem is dealing with basically the entire unit circle. So I can start at length 0 and work my way all the way around the entire unit circle. So anywhere where I'm highlighting, I can have a solution to my my equation that I solve. And again, I want to use my 6 steps to solve, and I want to replace this time my cosine of theta with an x, solve for the x, and then switch back to sine of theta. So let me write 1 through 6 to represent my 6 steps. 1, 2, 3, 4, 5, and 6. All right. Do I have a fraction to? Actually, let me switch my cosine of theta to an x. So I get x over 2 equals the square root of 2 over 4. All right. So do I have a fraction to eliminate? Yes, I do. So let's start with this first fraction. And what I'm going to do is multiply both sides by 2. Okay, and that's going to cancel that x on that side. And now I'm left with x equals, I'll put this 2 on the other side, x equals 2 times the square root of 2 over 4. Well, I can reduce this. And this would reduce to, let's say, I can divide out a 2 up the top. I can divide out the 2 at the bottom. So this is going to reduce to the square root of 2 over 2. Now remember, x replaced my cosine of theta. So I'm going to bring back my cosine of theta. And cosine of theta is square root of 2 over 2. So what this equation is asking us is what length has an x-coordinate of square root of 2 over 2. So what length has an x-coordinate of square root of 2 over 2? Well, there would be 2 locations that have that length. I'm sorry, there would be 2 locations that have that x-coordinate. Pi over 4 and 7 pi over 4 would have the x-coordinate. So here the length that would get us there would be pi over 4. You can verify that. And 7 pi over 4. So these will be the lengths that have that as my x-coordinate on the unit circle with that restricted domain. Now again, I have the same equation, but this time I have a different domain, or a different restriction, sorry. And I'm allowed to go from pi to 2 pi. I'm allowed to go from pi, so I'm going to erase this until I get to pi. I'm not allowed to be here. So I'm allowed to go from pi to 2 pi. So in the previous problem, I had an answer here and here. But notice in this problem, this is not shaded red. So my answer for this second version of the same problem with a different restriction is only going to be in that location. So for this problem, the answer would be theta is equal to, not even close to 7. Theta is equal to 7 pi over 4. So again, your answer has to be based on the restriction. So again, I wanted to show you how we can solve simple linear trig equations using the 6 steps. Understand how solutions can be restricted and what form the solution is. We want to replace our sine or cosine of theta with x, solve, switch back. And again, make sure you understand where your answers can be. So I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.